Your next reading is Portfolio Risk and Return Part 1. A quick overview. These are the specific learning outcome statements. So let us do them one by one. First, calculate and interpret major return measures and describe their appropriate uses. So we have 6-7 measures of return: holding period return, arithmetic return, geometric, money weighted rate of return, annualized return, and then finally the portfolio return. So let us just discuss them briefly. Holding period return. Holding period return basically refers to the change in the value of an investment over the period it is held, and it is expressed as a percentage of the original invested capital. So here you can see the formula: ending value of the assets you hold minus beginning value plus any income generated by the asset, of course dividends or interest, divided by the beginning value. So you can just give it in these symbols: P1 representing the ending value, beginning value, plus interest or any dividends upon the initial value, the beginning value. And then let's just try a question that will explain the idea. Okay, 5 years ago, a trader paid $20 per share for 500 shares in an insurance company, which means the initial value of the investment would be 20 times 500, that is $10,000. The current share price has grown by 50%, means now the current price is 30, that is 20%, $20 times 1.5, and multiply this with 500 shares. Now the ending value is $15,000. Okay. So far he has received 12 dividend payments, each amounting to 0.5 per share, right? 12 payments, each for 0.5, and there are 500 shares. So this is what he has generated over the period. So applying the same formula, ending value minus the beginning value plus the income generated, the asset income, divided by the beginning value. So you get 30%. So this is how we calculate the holding period return. There is one important point to be remembered here, that holding period return like this 80%, it needs to be considered whether this 80% has been earned over a period of 1 year, 2, or maybe 20 years. So this is important. Just 80% itself doesn't mean anything unless you have in mind what is the total time period for which the investment was held. Then next we have arithmetic return. It is a simple average of the holding period returns. If you just add all the returns and divide it with the number of periods. Let's say, for example, we have these returns, these holding periods, and 25%, 10%, 12%, and negative 3%, for example. So these are the last 4 years returns. So if you just simply add them up and divide with the 4, what you get is 11%. So this is what you call the arithmetic return. We have already done these averages in your quants section of the CFA level 1. Arithmetic mean is sometimes referred to as an unbiased estimator of the true mean. But there is an important point to be remembered, that when there are significant negative returns, the average return could be misleading. This is an important point to be remembered. Then we have the geometric mean returns. Okay, now what do we do in the geometric mean return? Geometric mean return basically gives us the average rate per period on an investment that is compounded over multiple periods. Let's just take these returns and use this formula for geometric mean return. 1 plus holding period return for the first period times 1 plus holding period return for the second period, that is 10%, 1 plus 12%, and then since it's negative, so it's going to be 1 minus 3%, right? Since there are 4 returns, so we're going to take the fourth root, that is here 1 upon 4 minus 1. So you can just simplify it: 1.25, 1.1, 1.12, and 0.97. Fourth root subtracted from 1 should give you the geometric mean return of 10.6. So it will give you a return compounded over multiple periods. In this example, 4 periods, 4 holding periods. An important point that must be remembered that when the periodic rates of return vary from period to period, the geometric mean return will have a value that is normally less than the arithmetic mean return. Now, next, money weighted rate of return. Money weighted rate of return is basically the return that accounts for the money invested and provides the investor with the information on the return that he or she earns on her actual investment. So its calculation is similar to that of the internal rate of return and the yield to maturity. I have some good questions in your EOC, so I recommend right now at this point in the lecture, you should go straight to that particular video where I have solved the end of chapter questions on portfolio risk and return part 1 from your CFA curriculum. There are 4 to 5 very good questions. I will give you the question numbers shortly. Yes, that's question number 5, question number 6, question number 7 in your EOCs. Excellent questions that will explain you the complete computation involved in calculating the money weighted rates of return. So I hope this will help. And as I said, computations are similar to those of IRR and the yield to maturity. You can just see these questions and then you will learn what is money weighted rate of return and how do we calculate. Then we have annualized return. Well, annualized return, let's say when the returns for a period is less than 1 year, then the return for that period must be compounded by the number of periods in a year. For example, the monthly return is compounded 12 times. Weekly return is compounded 52 times. The quarterly return is compounded 4 times, and the daily return is compounded 365 times. And of course, you would know from your earlier reading that there is continuous compounding that involves E as well. Right, moving on, next, portfolio return. Okay, so let's say you have 3 assets in a portfolio, ABC. You invested 30% in investment A, 50% in investment B, and you have invested 20% remaining in the asset C. And this is the weightage. Let's say the return generated by A, let's say 10%, B 15%, and C 8%. So when we say portfolio return, we simply take the weighted average return. 10% of 30%, that is 3%. Then we have 50%, 15%, that is 7.5. And then 20% of 8 or 8% of 20, that will give you 1.6. So adding this all up will give you the portfolio return. So that will be 12.1%. And this is the formula we use, weights and the return generated by individual assets in the portfolio. Then there are gross returns, net returns. When you say gross return is earned prior to the deduction of fee, normally the management fee or the custodial fee. But when you say the net return is the return post deduction of fees. All right, then we have another measure called the real return. Real return can be calculated by dividing the 1 plus nominal return divided by 1 plus the inflation rate. Let's say you have generated a nominal return of 5%, and over the period the price level has gone up by 2% inflation. So there is a 3% real return. But if you want to calculate accurately, then you will take 1 plus nominal return upon 1 plus inflation rate. That will give you the real return, excluding the effect of inflation. So that would be roughly 2.94%. That's the value of the real return. All right, moving on. Understanding, okay, now what do we have? Compare the money weighted and time weighted rate of return and evaluate the performance of portfolio based on these. We've just discussed that the money weighted rate of return, also known as the internal rate of return, it takes cash inflows and outflows into consideration, and it is directly related to your actual money earned. Whereas the time weighted return, it compares your portfolio returns to a benchmark over a specific period of time, it illustrates how well the portfolio manager is doing with reference to the benchmark. As I said, there is a nice set of questions in the EOC, question number 5, 6, and 7. They will explain everything in detail. How do we calculate these? And then you will develop better understanding for these two. All right, moving on. Describe the characteristics of the major asset classes that investors consider in forming portfolio. First of all, risk-return trade-off. What it says that if you take high risk, then you are expecting high returns. So risk-return trade-off basically refers to a relationship between risk and return. So to achieve high return, you must accept a higher level of risk and vice versa. So this is what we have for the last 80 plus years. This is the data from 1926 to 2008, illustrating the various risk returns combinations for different asset classes. As you can see here, of course, we know from our quant study readings that standard deviation is a measure of risk. So look at this. When the standard deviation is the lowest here, you have the lowest average annual nominal returns. Of course, T-bills the safest and hence the lowest return. And look at these. US small company stocks having the highest level of standard deviation, hence the highest return. So if you take the highest risk, then there is higher return. That's what you call the risk-return trade-off. So to achieve high return, you must accept a higher level of risk, or if you take higher level of risk, you expect a higher level of return. Skewness, we are familiar with this. So we discussed this in detail in our quants reading. Skewness, basically, it is present when the distribution is not symmetrical. Now look at this. This is the one in orange color. This is a symmetrical distribution, but the other two, the green one and the blue, they are not symmetrical. One is the positively skewed one, and the other one is called the negative skewed. The reason being, the one that is positively skewed, it has a large number of negative returns and a few very large positive returns. The one that is negatively skewed, it has large number of positive returns and few very large losses, right? So this is a symmetrical distribution where mean, median and mod, they're perfectly within the center of the distribution. The one that is positively skewed, the highest number, this represents mod. Mod is less than median, less than mean. This would be true for positively skewed distribution. The one that is negatively skewed, in this distribution, you can see your mean is smaller than median and smaller than mod, right? So as I said, the distribution that is positively skewed, it has large number of small negative values here with a few large positive values. This distribution has a long right tail, and that's just, you look at this point here. And this distribution, which is negatively skewed, it has large number of small positive values with a few large negative values, as you can see. So the distribution has a long left tail. And now you've already, and this one that's in the middle, here the mean, median, mod, they're all the same. That's what symmetrical distribution is all about. We have read everything about these in our quant studies. So it's mean, median, and mod, they are all the same in the symmetrical distribution. Now, which one of these would an investor prefer? Investors would like positive skewness because the mean here is greater than the median. Look at this. All right, so moving on. Kurtosis. This is all from your previous studies. Just a quick overview. Kurtosis basically measures the degree to which the distribution is more peaked than the normal distribution or less peaked than the normal distribution. And here in between here we have the normal distribution, right? So when we say a distribution has positive kurtosis, So it means that it is relatively more peaked distribution than normal, called the leptokurtic kurtosis. And when we say it's negative kurtosis, the distribution is negative kurtosis, that would indicate a relatively flat distribution than the normal distribution. A normal distribution has a kurtosis of 3. A leptokurtic will have greater than 3 and the platokurtic will have less than 3. So an investment characterized by high kurtosis like this one, it will have fat tail ends. You can see here. It will have fat tail ends, that is higher frequency of outcomes. So for such a distribution that is exhibiting higher kurtosis, it will tend to overestimate the probability of achieving the mean return. This is all from your previous studies. I'm just now, even the next reading is from your previous reading from quants. This one. Calculate and interpret mean, variance, covariance of asset return based on the historical data. We have done it in detail in your quants, but let us just revisit. Variance of asset returns. What does it measure? It measures the volatility or dispersion of return. And how do we calculate this? It's basically the average squared deviation from the mean. Let's take an example here. Let's say we have these 5 years returns, 10.5, 8, 6, 12, and 13. First, we'll take the mean. How we take the mean? You add all these up and divide by 5. That'll give you 10.1. Then you take the deviations from the mean. This is the mean. So you're going to take 10.5 minus 10.1, 8.5 minus 10.1, 6 minus 10.1, 12.5 minus 10.1, and 13 minus 10.1. These are the deviations. Deviations squared. You take the square of these, you get the sum, that is 30.7, and simply divide the square deviations with the number of returns, that is 5, 6.74. This is what you call variance. And if you take the square root of this, this will become the standard deviation, the most widely used measure of volatility. So any stock that shows a higher standard deviation, it means it has more volatile returns. And any asset that has a relatively lower standard deviation means it shows less volatility. So you have, I'm sure, learned how to calculate your standard deviation and variance using the financial calculator from your readings. But if not, let's just do this using the financial calculator. I'll show you how to calculate the standard deviation and the variance using your BA plus 2 financial calculator. Just in a minute. Okay, so this is how you can calculate the standard deviation variance using your financial calculator. You press second, press 7, that will bring you to the data mode. Enter the first value, that is 10.5, 10.5. Press enter and press down arrow key twice because we're just dealing with X nor Y. Then enter 8.5, 8.5. Press enter, press down arrow key twice because we're just dealing with X. Then enter the next value, that is 6. Enter, down arrow key twice. Then enter 12.5, that is the fourth value, 12.5. Enter, down arrow key twice. And then last value is 13. 13. Enter and down arrow key twice. Now you will activate the stats function. Second, add that stat. So what do we need? We are looking for 5 values. Then there is mean is 10.1. The standard deviation, sample standard deviation, that is 2.9 and 2.59, which is approximately 2.6. This is the population standard deviation, right? So that's as simple as that. You can use your financial calculator to calculate the mean and variance, and that's all. So as I just said, that standard deviation or the variance, it's the measure of volatility. It's a measure of risk and one of the most widely used measure of quantifying risk. Next we have covariance. What is covariance? Covariance is a measure of how two assets move together, how two assets relate together relative to their individual mean values. So they can be, your covariance can be positive, a very large positive number, it could be a very large negative number, and it could be 0. So when the covariance is positive, which means then two assets, they move in the same direction. They move up together, they move down together. And if the covariance result is negative, that would indicate that they move in the opposite direction. If one asset moves upwards, the other falls, and vice versa. And if the covariance is 0, that would mean that there is no relationship between them. They move totally independent of each other. And this is how we can calculate covariance. I will show you in the next slide. And then there is an alternative way to calculate using the coefficient of correlation, standard deviation of the first asset, and the standard deviation of the other. Let me show you in the next slide. So here we have two assets. So these are the returns on asset 1, 5, 4.5, 4.8, 5.5, and 6. And these are the return on the asset 2 in the corresponding year 1, 2, 3, 4, 5, right? Now we would like to calculate the covariance between these two returns. We just want to measure how these two assets return, they are related. How do they move together relative to their individual mean values over a period of 5 years. Now what we will do, we'll apply the formula previously. First we need to calculate the mean for the mean return for asset 1 and mean return for asset 2. So we will add all these, this plus this plus this plus this plus this divided by 5. It gives us about 5.2%. Then we'll add all these returns and divide in 5. This will give us the mean return for the asset 2. Now, next, let me put the formula alongside here so you know what I'm doing. Now we're going to calculate the deviations from the mean for R1. Now this is mean 0.052 and this is the return in period 1, 0.05. So what you're doing 0.05 minus 0.052, 0.045 less 0.052, 0.048 less 0.052, 0.05 less 0.052, and 0.06 less 0.052. That gives you the deviations from the mean. You do the same for the returns on asset 2. That is 0.06 less 0.061, 0.062 less 0.061. Once you do for all these the deviations, then you just multiply these as per the formula, and that's what you get after the multiplication. When you add these up, summation of all these, this would give you the covariance, which is, you can see, close to 0, so which means these two assets are, returns are not related with each other. The strength of relationship is very weak. So this is what we measure through covariance, that how two assets relate together, how two assets move together relative to their individual means over a period of time. Alright, so we have another formula to calculate the covariance. Covariance between two assets is equal to coefficient of correlation between the two assets multiplied by the standard deviation of the asset 1 and the standard deviation of the asset 2. And using this formula, we can do it using your financial calculator. Let me show you how we can do that. Okay, press second data. Now you are in data entry mode. Enter first pair of data 5 and 6. 5 down, enter. For Y it's going to be 6. Enter. Second pair of data is 4.5. 4.5. Enter. Down arrow key. In that case, the pair Y has 6.2. Enter. Down arrow key. Then we have 4.8 for X and 5.7 for Y. Then we have 5.5 for X and we have 6.1 for Y. And the last pair is 6 for X and 6.5 for y. Okay, all data is entered. Now press second stat. We need LIN here, that is the linear regression function. So for that, keep on pressing second, enter. Yes, it's there. Now this down arrow key, there are 5 pairs of data. This is the mean for the first returns, that is 0.052, which is about 5.16 or 5.2%. This is the sample standard deviation of x, population standard deviation of x. Then the second return, that is denoted here by y. This is the mean for y, the second set of data, that is 0.061 or just 6.1%. That is the sample standard deviation, population standard deviation. And this is the coefficient of correlation. So you just simply need to use these in this formula. Let me solve this for you. So this is the population standard deviation of the second returns. This is the population standard deviation for the first one, the asset one, and R is the coefficient of correlation. So you can also use the store function in the calculator. I've just written it down. If you just multiply these all, you should get the covariance. Remember, these standard deviations are in percentages. So when you simplify them all and then divide the result with 100 twice in order to convert into the decimal, the final answer that you will get is going to be 0.000086, and that perfectly matching with the sum of these deviations multiplied. So that's how you can use the financial calculator to calculate the covariance. Okay, now if you take this row sign here as the subject of this equation and you divide covariance with the standard deviation of x and standard deviation of y, the first asset and the second asset, what you get is called the correlation coefficient or coefficient of correlation. So which basically is the relative measure of the relationship between the two assets. So the difference between covariance and correlation is that covariance can have an extremely large positive value, can have extremely large negative value, or zero. But the coefficient of correlation, it is range bound. It is greater than or equal to -1 and less than or equal to +1. It cannot go beyond these two limits. So a coefficient of correlation of +1 means that the two variables are perfectly positively correlated. If plotted against the coordinate system, it will be showing a line like this, maybe flatter one or steeper one, but it will be upward sloping. But if the two variables x and y, two assets, are negatively correlated, in that case the slope of the line would be negative. So it could be flatter or steeper, but it would be this way. And if the R is 0, it means the assets return are totally unrelated. So along this range of from 0 to -1 and +1, if we happen to have the coefficient of correlation somewhere here, let's say 0.86, strongly positive relations, 0.78, strongly negative, perfectly positive, perfectly negative. So we'll discuss this as we go along in our subsequent LOS session. Your next LOS, explain risk aversion and its implication for portfolio selection. There are 3 types of investors. Those who are risk averse, they would prefer risk-free asset. They run away from risk. Those who are risk neutral, so they don't care about the risk. They just need a certain return. And risk seeker, they prefer risky assets, right? So risk aversion is the tendency of individual of the behavior to how they respond to risk. So the first one, risk seeker, is the one who is looking for higher returns, and of course he would look for high risk. Risk neutral maximizes the return irrespective of the risk, and the risk averse one, he has very little or low appetite for risk, would prefer a low return that is guaranteed rather than a substantial risky return. Next, risk tolerance. Risk tolerance is basically refers to the amount of risk an investor is willing to take in order to achieve his or her investment goals and objectives. So basically a high risk tolerance shows a greater willingness to take risk. If you have high risk tolerance, which means you are willing to take on even higher level of risk, And low risk tolerance means that less willingness to take high risk. So you can say that a person who has a high risk tolerance will take on more risk, and a person who has high risk aversion will take less risk. So you can say that risk tolerance and risk aversion, they are negatively correlated. A person who has high risk tolerance will have low risk aversion. A person who has high risk aversion will have low risk tolerance, and vice versa. Next is calculate and interpret portfolio standard deviation. Next LOS is calculate and interpret portfolio standard deviation. What if we want to calculate the volatility of a portfolio that has two assets in them? So this is the formula we can use. Either you can use the covariance one or the one using correlation. Now, what these elements within the formula show. Let's say you have two assets, asset 1 and asset 2. The weightage, the proportion of the total investment in the asset 1 is W1 and the proportion in the second asset is W2. The standard deviation of the asset 1 and the standard deviation of the asset 2, and of course the covariance if calculated as represented as COV12. So if you just use this formula, weight 1 squared standard deviation, or called variance, weight 2 squared variance 2 plus 2 times of weight 1 weight 2 into covariance, it will give you the combined volatility of these two assets together in a portfolio. So here we are using the covariance. We just learned previously that covariance is equal to the coefficient of correlation, standard deviation for asset 1, standard deviation for asset 2. So if we just replace covariance with this combination, here we go. So we have an alternative way to calculate the portfolio variance using the correlation. This is the variance of the portfolio using covariance, variance of the portfolio using correlation. What if we want to calculate the standard deviation? Simply take the square root. Take the square root, you get the standard deviation. And here you do the same thing. Now, let us do some good example here. From the information given in the table, calculate the portfolio risk and return. We have two assets, asset 1, asset 2 with the weight 80 and 20. The expected return 9.98, 15.8, standard deviation given, and the covariance is also given. So we have to calculate three things: the portfolio return, the portfolio variance, and the portfolio standard deviation. How do we do that? It's very simple, straightforward. 80% weightage to asset 1 has a return expectation of 9.98%, weighted average. 20% weight to asset 2 at the rate of 15.8%. So if you simplify, you will get 11.14. So this is the expected return on the portfolio. Now, if you need to calculate the variance, what you will do, you just learned the formula previously, this one. Using the variance approach, this one. So what we're going to do, 0.8 squared times 0.17 squared plus 0.2 squared times 0.3 squared plus 2 times of the first weight times the second weight times the covariance 0.005, right? So if you simplify, you will get 0.023696. This is the portfolio variance. So if you want to calculate the portfolio standard deviation, simply take the square root of this and you will get 0.1539, which is 15.39%. Now this is a very interesting situation here. If we invest in asset 1 alone, we face a risk of 17% standard deviation. For asset 2, it's 30%. But if we invest in a combination of 1 and 2, look at the volatility. It has fallen from 17.30 to just 15.39. So should the investor invest in asset 1 or 2 or both? So not entirely in asset 1, not entirely in asset 2, rather a combination of 1 and 2, so as to reduce the overall risk of the investment. So our conclusion is that he should invest in both, because portfolio risk here is less than the risk of each respective asset of 17 and 30% respectively. Okay, now let's take on the next scenario. Next, LO says describe the effect on a portfolio's risk of investing in assets that are less than perfectly correlated. So how does correlation impact portfolio risk? As I said, that correlation ranges from +1 to -1, coefficient of correlation. So when the correlation coefficient is +1, this way, and the returns are positively correlated or perfectly positively correlated, or when the returns are negatively correlated, or when they are unrelated. When the coefficient of correlation is +1, the risk is unaffected. No diversification benefit arises. But when the correlation coefficient is -1, the overall portfolio risk is eliminated. There is a maximum benefit of diversification. But if it falls somewhere between these, when the assets are not perfectly correlated, then you will see that the overall risk would reduce, the portfolio risk would be reduced, and there will be benefit for diversification. Let us see some examples one by one. Look at this first. Okay, now let us just plug in the numbers here to find the portfolio standard deviation. The weight is 0.5 squared, 0.3 squared, then next combination, 0.5 squared times 0.3 squared plus 2 times of 0.5, 0.5 times the coefficient of correlation, that is 1, and the variance, that is 0.3 and 0.3. So if you simplify all of this, interestingly, you will see that the portfolio standard deviation is 30%. So basically, when the assets have positive correlation of +1, then there is no risk reduction. Portfolio risk is unaffected. It is simply the weighted average of the standard deviation of the two assets. So basically, there is no risk reduction. Now let us take on another situation. In this case, the coefficient of correlation is 0, which means when you will replace 0 with this whole element will become 0. So what you will have, basically, the weight 1 squared, 0.5 squared, times standard deviation 0.3 squared, plus 0.5 squared plus 0.3 squared, and then the square root of this value. So you'll get 21%. Yes, portfolio risk is reduced with the addition of two assets that are not perfectly correlated. So when the correlation coefficient is 0, so yes, there has been a risk reduction, right? Then let's take the third case. Here the correlation coefficient is -1. So in this case, when you will calculate this, all the numbers you plug it, you will get maximum risk reduction. You will get the maximum risk reduction. The portfolio volatility of the standard deviation becomes 0, right? So this is the maximum risk reduction, and it would occur when the addition of two assets that are perfectly negatively correlated. Now we just go back. So this is your portfolio variance, and this becomes your portfolio standard deviation. Now look at this. It all depends upon the coefficient of correlation. If it is 0, this element will become nil and the portfolio risk will reduce. It means when the coefficient of correlation is 0, then you are left with just these elements, and then of course it will reduce the standard deviation of the portfolio. Now in the second case, when the coefficient of correlation is +1, when it is +1, you will have a larger solution. This means that the risk reduction is none or very little. And when the coefficient of correlation is -1, in that case, this part will become negative and it will reduce the overall result, and then in that case, the risk reduction would be the maximum. Or if it is close to -1, let's say it's maybe 0.70, you will get quite a lot of risk reduction. So if the portfolio elements are negatively correlated, perfectly negative, risk would be eliminated. If it is closely or strongly negatively correlated, then there will be significant risk reduction. And that's how things go. Next is describe and interpret the minimum variance and efficient frontiers of risky assets and the global minimum variance portfolio. What is an efficient frontier? Although there are no securities with perfect negative correlation, irrespective of the example we did previously, almost all assets are less than perfectly correlated. Right? So therefore, if we can reduce the total portfolio risk through diversification, and if we consider many assets at various weights by changing the weights, we can generate an efficient frontier. Now, what is an efficient frontier? The efficient frontier represents all the dominant portfolios in risk return space. These are your dominant portfolios. And what is a dominant portfolio? A portfolio dominates all others if no other equally risky portfolio has a higher expected return, or if no portfolio with the same expected return has a less risk. So all these portfolios on this curve here, they are called the dominant portfolios, and this line here is called the efficient frontier. Now, how is it constructed? Let us assume we have some risk return characteristics of some about 20 assets. So with the help of the computer, what we can do, we can calculate all possible portfolio combinations, and these are plotted here. The collection of all the minimum variance portfolios would form a minimum variance frontier, as you can see through this line. So along the minimum variance frontier, the leftmost point here at this point here, this is called the global minimum variance portfolio. This portfolio has the minimum variance when compared to all the possible portfolios. And what you call the efficient frontier is the portion of the minimum variance curve that lies above this point, above the global minimum variance portfolio. Now, how does it help us? Why there is so much emphasis on the efficient frontier? So these portfolios that are lying on this line, on the efficient frontier, they offer the maximum expected return for their level of variance of returns. Now, all these below this line, they are inefficient portfolios. Why? Let's say, now consider this one. Now at this risk level, this portfolio is providing this much return. But the portfolio that is right above this on the frontier, it is offering you a high return. So two portfolios at the same risk, comparing this offers the highest return. So that's what we mean here, efficient frontier. They provide you the maximum expected return for their level of variance of returns. Take any other example, like maybe here, this portfolio here and this versus this. So clearly they both have the same risk, but this one offering a higher return. So on efficient frontier, we have those portfolios that provide you the highest level of return for the given risk. And why is it so? Because the efficient portfolios, they use risk efficiently. Investors making portfolio choices in terms of mean return and variance of return can restrict their selection to those portfolios only that lie on the efficient frontier. So this simplifies the selection process. Okay, next, explain the selection of an optimal portfolio given an investor's utility or risk aversion and the capital allocation line. So what is utility theory? You would have read in your economics. Utility means satisfaction. So when you say utility, we means relative satisfaction between different combinations of risk and return. Relative satisfaction from consumption. That's the idea we discussed in economics way back in your undergraduate studies. So basically, utility theory is the foundation that will help us rank our choices. That is quantification of our rankings of choices, which we prefer first and the second and then third. Utility, the satisfaction is different for different investors. Investor A has different level of utility function, B has different, C has different. Utility can be increased. How? By getting a higher return or putting the investment in lower risk. Utility can also be decreased if the risk increases. Right? So there are certain assumptions in this theory. Investors are risk averse, they avoid risk. There is a possibility to rank order. I'll show you in the next slide. And the rankings are internally consistent. Let me show you in the next slide. Here we have different combinations of risk return pairs acceptable to an investor for a given level of utility. Let's say here, if an investor is at A or B, he is equally happy because at position A, at a certain level of risk, he's getting this much return. But when he moves from point A to B, he is surely facing higher risk, but it is being compensated by higher return. So basically, this is what you call indifference curve. An investor is indifferent whether he's at point A or point B. All points on a curve, they have the same utility. So investor is indifferent between point A and B. Similarly, an investor who is on the moderate utility indifferent curve, he will be indifferent between point C and point D. So remember, a curve with the higher return for a given level of risk is superior than a curve offering the lower return for the same risk. What does it mean? Let's say here, if the risk here is, let's say 17%, and there are these three indifference curves. So a curve with the higher return at the same risk is superior to the curve offering the lower return at the same level of risk. So for me, this would have a more utility, less utility, and low utility. So we can also show risk aversion through this way. A risk lover is just interested in taking on risks. Even the returns are falling. Look at this. He's looking for risk, risk loving, risk seeking. Whereas the one that is risk neutral, he needs a certain return irrespective of the level of risk. And the investor with the low risk aversion, he needs to be compensated for any additional risk he may have to face. And the one that is highly risk averse, he needs a much higher return to compensate for the higher risk. So the steeper this curve, the more risk averse the investor is. The flatter, the less. And if the curve is a horizontal line, then we say the investor is risk neutral. So we can see here that when the slope of the indifference curve is the highest, there is more risk aversion. And when the slope is lesser, so in that case, there is less risk aversion. Next is the capital allocation line. What is a capital allocation line? Basically, it's the combination of risk-free asset and a risky asset. And what is a risky asset itself? It's this risky asset is the multiple portfolios available to the investor, the combination of risky assets. So if we combine risk-free asset with the risky assets, the line that is drawn using different returns is called the capital allocation line. Let me show you. Now this is the risk-free asset generating return RF. So as you keep on adding risky assets, the return will tend to increase. And let's say take this position, we just like to draw a line representing this capital asset allocation. Now let's say we are at this point. We want to drive an equation first. We know that the equation the line is represented y is equal to a plus bx. Right here, our y represents the expected return on the portfolio. A, the y-intercept, is the risk-free rate. X, on the x-axis we have the portfolio standard deviation. And in place of b, what we will do, we'll need to find the gradient of this line. Now how do we find the gradient? That is y2 minus y1 over x2 minus x1, right? So what is y2 minus y2 is the expected return on the risky asset minus risk-free rate, that is y1, upon the variance of the asset minus 0. So that gives you ERI minus risk-free rate upon the standard deviation of the asset. This equation represents the capital asset allocation line shown right here. So addition of the riskier assets in the portfolio will increase the overall return of the investor by this variable coefficient factor in this. Now, to get the optimal portfolio, we need to combine the indifference curves with the capital allocation line. Now look at this. This is our capital allocation line, and it is intersecting this indifference curve 1, and it is tangent to this indifference curve 2, which means we have these 3 different portfolios. Now if we go for D, that is on the lower indifference curve, having lower utility. If you go for E, again, that will be on the lower indifference curve and having lower utility. But look at this one. This portfolio is tangent to the higher utility curve, having higher satisfaction for the investor. So out of these, he will go for this one. So this is the optimal portfolio, the portfolio that is tangent to the investor's highest indifference curve, that touches the, or that is tangent to the capital allocation line. So this is the one that you call the optimal portfolio out of the remaining portfolio, the most suitable portfolio. And that ends your reading Portfolio Risk and Return, Part 1.